Hello everyone. So in this video we are going to prove the linear regression equation that we have discussed in previous couple of videos, that how we use the linear regression to predict the unknown value. And like I mentioned, normally the model itself is a black box for us. We don't need to open that box and investigate. But sometime once we are applying these machine learning algorithms and we want to investigate or even improve the outcome or reduce the error rate. So these instances, it would be good if we can open the black box and understand the internal working, which is obviously completely based on the mathematical modeling that has already been developed and approved by the expert in the industry. But for us, it would be always easier to get more control and more power if we understand the underlying mathematics. So what we're going to do, we're going to actually look at the equation, and we're going to prove the formula. And if you remember, the linear regression equation was, which we discussed, is y is equal to mx plus c. And let me draw the diagram, because obviously the diagram will help you to understand the concept in a better way. So you can see we have 2 points on this line. The line is straight. One thing you need to remember, whenever we have a straight line, the ratio of the change between x-axis and y-axis value is always going to be constant. And that's why the slope of the line, which is actually nothing but the change in the y-axis in term of x-axis, is always going to be constant. So in simple term, what we do, normally how we calculate the scope, we calculate the difference in the y value divided by the difference in the x value. So for example, if the object is moving from here to here on this line, so whatever the change happens in both axes or in both dimensions, the ratio between those changes is equal to the slope. And that's why on the straight line, m always remain constant. So regardless if we have a point y1 or x1, the slope is going to be same as we have on y2 and x2. And the same thing if we have, sorry, let me change the color. Even if we have n number of points, the slope will be unchanged, same as the constant, which is c. And what c refers in here, if we extend the line, that line is going to touch the y-axis at some point, and that point we normally refer into linear regression as a y-intercept. And what is y-intercept? It is a point on y-axis where x value is 0. So if we actually draw a point on this line, for these points on this line, all the values of x are going to be 0, right? So these points are easy to calculate. The similar concept apply in here. These are the x-intercept, because the y value on these points are going to be 0. So these are the basic understanding you need to keep in your mind. So that's the, now what we are going to do, if we know the m and c, that means if we have, for example, a value y dash, x dash plus c. So if we have a point where we know x dash is known, for example, x dash is, let me take a value of a, then I am able to identify the value of y dash given m and c are known. Right, so that's the whole analogy. And keep in mind the solution of linear regression equation is different for one variable, which is very rare in the real life, and for multiple independent variables. So right now what we are doing, we are resolving our linear regression equation for one variable. So that proof is going to be different, and once I will show you, once we have more than one variable, how we can solve that as well. All right, so let me see if I can prepare more space. It doesn't look like it's gonna. All right, so what I can do, can I hide the controls? I'm using it on a device where I don't have enough space, so I'm just looking at the solution. What I can do, let me see. Okay, the zoom control are showing in between. All right, I'm just going to now share a new dashboard, so a new whiteboard with you guys, and we will do the math there. All right, we are back into the business. So let me write the equation. So for example, we have point xy1 is equal to mx1 plus c, and we have point y2 is equal to mx2 plus c. Now what I'm going to do, I'm going to, let me call it, that's equation 1 and that's equation 2. I'm going to subtract equation 1 from equation 2. So obviously how we subtract the equation, we subtract the left side from left side and we subtract the right side from right side. A very basic algebraic process. So y2 minus y1 is equal to mx2 plus c. That's the whole side. That's why I'm putting them in the bracket, minus the right side is mx1 plus c. Now let me open the bracket, mx1 x2 so plus c, and that minus will change the signs in the inner values. So it's going to be minus mx1 minus c is equal to y2 minus y1. So c is going to be cancelled in this equation, and we're gonna have y2 minus y1, and we remain mx2 minus mx1. Now m is coming as common, so I'm going to take m outside, x2 minus x1 and y2 minus y1. Okay, so if I actually divide x2 minus x1 on both sides, so this side will be minus divided by x2 minus x1 is equal to m x2 minus x1 is divided by x2 minus x1. So this side will cancel with this one, and we remain m with y2 minus y1 divided by x2 minus x1. So which is m is equal to change in y divided by change in x. So that's the formula that we have actually derived for our slope. And like I mentioned in the previous screen, we have seen that that change will remain constant all across. So let me just correct this one. Now, the only thing which I need to calculate is the value of c, because we have now m in terms of y2 minus y1, x2 minus x1. If we can calculate the m, that remains same for all the points on that line, right? So any point that we are going to calculate using that m will remain constant for that line. Now, the only thing which we are going to calculate is how we are going to calculate c. So I don't think I have enough space in here. I'm just going to share the new whiteboard. All right, so let me write down what we have from the previous screen. We have calculated y, which is equal to, sorry, we calculated the m, which is equal to y2 minus y1 divided by x2 minus x1. Now what we are going to do, let me write down the original equation. If you remember, y1 is equal to mx1 plus c, and y2 is equal to mx2 plus c. Now we can use any of the equation to derive the value of c, because c is, if you remember, is the y-intercept, which is also going to be constant considering the line is straight. So let me put the substitute value of m in equation 1. So what I'm going to do, y1 is equal to, my m value is y2 minus y1 divided by x2 minus x1 into x1, right, plus c. So let me take the whole side on the, move the equation on the sorry, move the first part of the right side towards the left side, because that will then remain c on the right hand side. And then obviously that movement, if you understand the algebraic operation for equation, you know, once we move one value from one side to another side of the equation, it will just change the sign of the value. So what will happen? Our final equation will be y1, and we are moving this full term, so that will become y1 minus y2 minus y1 divided by x2 minus x1 into x1, that's the multiplication sign, is equal to c. So that's the value of c that we can derive for that equation using that we can derive with these two equations for any unknown values of y. Now, considering we have the value of c, we have the value of y, sorry, we have the value of m. So with these two values, if we are given any value of x, we can determine the value of y. So now that's the proof for the equation of line for linear regression, considering we only have one independent variable, and we are trying to predict the dependent variable based on that single independent variable. So hopefully you understand the math. I try to keep it simple. You can download these whiteboards in the image. I'm going to put the link in the description. I'm going to upload them into my Git repo with the video. So please like or comment if you have any question or anything unclear. Otherwise, stay tuned to see the equation of linear regression for multiple variables. Thanks for watching.